Hello everyone and welcome back to my system design series. In today's video, we are going to explore these topics. Whether you are preparing for a system design interview or just curious about how large-scale applications work, this video is for you. So let's get started. Imagine you are running a large restaurant. You have a head chef and several cooks who help to prepare the meal. In the tech world, each computer and each server are kind of node in your restaurant's kitchen. In the distributed system, each nodes work together, process and store the data. But what happens when one of your node, or maybe you can say that one of your cook goes down, either unexpectedly or for planned maintenance? The system needs to be working just like your restaurants keep serving to customers even if one cook is not available. This is where the leader-based replication come into the picture. We have two main scenarios to discuss. First is follower failure and catch-up recovery, and second is leader failure and failover. Let's begin with the follower failure. Imagine one of your cook needs to leave the kitchen, maybe for a short break or due to some emergency. Before leaving, the cook keeps a diary noting every order the head chef gives. This diary is just like a log which is kept by each followers in our system. When the cook comes back, they simply reads this diary to see what orders they have missed while they were away. Then they ask the head chef for any extra instructions that came in during their absence. Once caught up, the cook goes back to work seamlessly. In technical terms, the follower node reads this log, connects to the leader and replays any missed data changes. This process is called catch-up recovery. It is like reading minutes of meeting you have missed. Everything is recorded so that you can get back quickly. Think about your day. You have missed an important meeting, but thanks to the minutes of meeting, that is a kind of notes of the meeting, and then you are back to the loop. That is exactly what happens in the distributed systems. Any questions so far? If you have, then you can drop down in the comment sections and then we will move forward. Okay, now let's tackle a more challenging situation, that is a leader failure. In our restaurant analogy, what if our head chef can't make it to work? Without someone to coordinate the orders, the whole kitchen comes to a halt. But distributed systems have a plan. Here is how it works in the 3 steps. First, detecting the failure. Second, choosing a new leader. Third, reconfiguring the system. Let's break down one by one. In distributed system, nodes keep checking in with one another. It is like the team in our kitchen always looking to see if the head chef is giving instructions or not. If the head chef doesn't respond, for example, for maybe 30 seconds, then everyone assumes that something is going wrong. It is similar like you are calling someone on phone and if you don't get response and after some rings, you assume that they are unavailable. This is the timeout mechanism that is used to decide that the leader might be down. Okay, let's move forward. Once the team decides that the head chef is not responding, it is the time to choose the new leader. The idea is to pick one of the cook who is most up to date, the one who is paying the closest attention to the orders. That way there is a minimal loss of information. Think about a sports team. If the captain gets injured, the player who best understands the game takes over. That is exactly what happens here. Sometimes the system automatically elects the new leader without human intervention. But just like a team, the coach or manager comes into the picture when everything gets messy. Now that we have a new head chef, it is important that everyone who is working inside or outside the kitchen knows this change. In our system, this means that reconfiguring the clients and other nodes so they can send the new request to this new leader. Imagine you have ordered a meal online and the restaurant's website suddenly shows the new chef's name as an in charge. The kitchen needs to make sure that your order goes to the right person. Similarly, the system needs to tell to all the nodes that hey, send your request to this new leader. But there are challenges here. What if your older leader comes back? It might still think that he is the head chef. The system has to ensure that the old leader steps down and joins as a cook so that there is no confusion. Handling leader failure is complex and there are several potential pitfalls which we need to take care. Let's go over some of the common challenges. First is unreplicated writes and data loss. In systems using asynchronous replication, The new leader might not have all the latest orders while the older leaders falls out unexpectedly. It is like missing a few instructions while shift change. Some details might be lost. Second is inconsistencies between the system. A real world example comes from the GitHub where an outdated follower has prompted as leader. This led to a situation where primary keys or unique IDs are being reused. Imagine two customers sitting at the restaurant and ordering the food and both of them getting the same order ID, which will cause the confusion and chaos. Third is split brain. In some cases, two nodes might think that they both are the head chefs. This split brain scenario is very dangerous because if both of them start processing the orders, chaos will increase and you might lose or corrupt the data. It is like fighting over who should lead the kitchen. Fourth is choosing the right timeout. Setting the right timeout is the balancing act. If it is too short, you are risking the unnecessary leader changes during temporary slowdowns. And if it is too long, you are delaying the recovery when it is a failure. While these challenges sound daunting, many modern systems uses sophisticated algorithms and consensus protocols like Paxos and RAW to ensure that even the things goes wrong, the overall system stays reliable. Before we wrap up, let's talk about some of the practices that engineers use to minimize these issues. First is regular monitoring. Keep an eye on system performance so that failures can be detected quickly. Second is grateful shutdowns. Plan for maintenance by ensuring that nodes can be taken offline without disrupting services, like scheduling breaks for your kitchen staff. Third is consensus protocols. Utilize the algorithm that help all the nodes should agree who the new leader will be, which will minimize the risk and split brain. Fourth is redundancy. Always have backup plan. If one of the component fails, others can take up. Recent examples have shown that even the large tech giants such as Twitter, Slack, large cloud providers are facing this kind of challenges. They continuously refine their system to handle the outages gracefully, learning from the past incidents to improve reliability. Okay, let's sum up. Handling node outages in distributed system with leader-based replication is all about being prepared for the failures. Whether it is followers catching up on a misorder or a whole team failure when a head chef goes down, every part of the system plays a very important role in maintaining the high availability. So that's it for today's video and I hope you have liked this video, understood the concept, then make sure you subscribe to this channel, give a thumbs up and comment down if you have any doubts. Thank you so much for watching.